Hi and welcome to this second module of the course. In this series of videos we are going to talk about RDF and RDFS, two of the main standards of the semantic web and linked data. We will start by a brief introduction to the concept of data representation in the semantic web, and then we will talk about the components, serialization and inference in each one of them. RDF stands for Resource Description Framework, and its goal is to describe the information semantics in a way that can be consumed both by humans and machines. As in many other areas of computer science, we can define two different levels. One for the schema, defining the structure of the data, and other for the data itself. On the database world, we have the entity relation schema, which defines the tables and keys to be used, and the data is stored in the corresponding database. On XML, we have the XSD files defining the schema for the data and its hierarchy, and then the data itself is stored in an XML file. When working with RDF and RDFS, we have the schema defined by RDF schema, and the data is stored on triples in RDF. In both cases, as we will see, we can choose between different serializations, all of them provided as recommendations by the W3C. We can understand the semantic web as a set of layers, each one of them built on top of the other. Every layer adds new features and functionalities in an incremental way. On the bottom of this image, we can see how the identifiers and characters are the base on top of which we build the XML syntax, which is one of the several syntaxes supported on RDF. On top of it, we have RDFS as the layer for data interchange based on RDF. Based on it, we have RDFS for defining taxonomy and data model. In this other picture, we see how RDF model and RDFS, along with other languages, are also supported by syntaxes such as Turtle or JSON as well. So let's take a deeper look at RDF. The main pillar of RDS and thus of the semantic web are triples. Triples are a set of three elements joined together. These triples contain a subject, a resource from the world that we can identify and that we can describe, such as, for example, a person, a car, a place, for example. Then the predicate, which can be seen sort of as the verb in a sentence, defining a certain characteristic of the subject, a property of the subject, such as its color, for example, or how it relates to other resources. Finally, we have the object, which can be either a resource, as in the case of the subject, or a literal value, for example, a numerical value, or a date, or a string containing information. We can use simple sentences as an analogy, as an example of statements that can be represented in triples. For example, if we want to say that Raúl is a member of the ontology engineering group, we can identify Raúl as the subject, then is member of, the verb as the predicate, and finally the ontology engineering group as the object. If we want to specify in this example, for example, that Raúl has a full name, that Raúl's full name is Raúl García Castro, we can say that Raúl is the subject as well, has full name is the predicate, and Raúl García Castro is, in this case, a literal, a value. We can specify as well that Raúl was born in December 26, 1975, which again we say Raúl is the subject of the triple, has birth date is the predicate, and the corresponding date is the object. Finally, we can say things about, for example, the ontology engineering group, another resource. We can say that the homepage of the ontology engineering group is the URL that appears on the slide. We say that the ontology engineering group is the subject, has web page is the predicate, and the value of the URL is the object. In this set of triples or annotation, we can distinguish two main types of elements. We have, on the one hand, Raúl, which is a resource representing, in this case, a person, and then the ontology engineering group, another resource representing another entity, in this case a research group. In both cases we are using resources. We can also use values, such as for example strings for defining Raúl's name, a date for his birthday, or the URL for the web page of the ontology engineering group. These values, as we will see, can be typed using different standardized formats. In RDF, data is organized in graphs. Each graph is composed by a set of triples. If we take all the triples from the previous examples that we saw, we will have the following graph. We have Raúl as the main node on the graph linked with the other nodes by means of different properties. A set of graphs is called a dataset, as stated by RDF 1.1 specification. In each dataset, there is at least one graph, which is defined as the default graph, and then 0 or more named graph, which we can access based on this name. That is, we can divide the information, we can clusterize it based or using different names or IDs. As we have introduced before, the object in a triple can be either a resource or a literal value. These literals can be defined as data types. That is, we can define the data type for this value. Usually these types are defined by means of XML schema data types. As well, we have some extra RDF data types, as the ones shown in the slide, including, for example, the language as a tag, or types for XML or HTML literals. Here in this example, we see how we have defined the format XSDDate for Raúl's birthday. There is a wide list of types that can be used when defining types in RDF, such as booleans, integer, or float, as well as dates in several formats. The complete list of these formats can be accessed on this link that you have on the materials as well. So in this first video, we have introduced the role of RDF and RDFS in the semantic web. We have also introduced the basic concepts from RDF, mainly triples, and in the coming videos, we will explain in more detail both RDF and RDFS.